Sauce here. This is a video lesson graphing slope-intercept form. I have an example already here. Y plus 6 is equal to 1/2 times x. This equation belongs to the family of linear equations. The graph of this equation is going to be a line. I could proceed, because it always works, to create a t-table, select some values of x, use the equation to calculate y. But I've learned of the slope-intercept form. I could take advantage of making this equation or putting it into slope-intercept form so that I could easily and quickly identify the slope and the intercept and then use those two numbers to graph the equation very quickly. The first step in using slope-intercept form to graph is that I want to put the equation into that form. Very often when we're given linear equations to graph, they may already be in slope-intercept form, but not necessarily. So as a reminder, slope-intercept form is y is equal to a number times x plus or minus another number. The variables in this equation are x and y. The number that multiplies x we often choose to represent as m, and m is the slope of the line. B is the y-intercept. We often choose the letter b to represent the y-intercept in the general equation. This equation here that we're going to work with is not in slope-intercept form. It's not even solved for y, but I can change it by subtracting 6 from both sides to eliminate adding 6, which we would leave y by itself. And on the other side, I don't combine these terms. They're not like terms. So I'll represent it as 1/2 times x that was already there, and then subtract 6. By solving for y, I also got this equation in slope-intercept form. Y is equal to a number times x, in this case 1/2, plus or minus another number, in this case I'm subtracting 6. So in this equation, the number that's multiplying x is the slope. And the slope of this equation is 1/2. The number that I'm adding or subtracting is the y-intercept. Could abbreviate it y-int, and that's equal to -6. Once I've identified these numbers, I can go straight to graphing. I have my x and my y-axis drawn. I'm first on the y-axis going to find the y-intercept at -6 if I count 6 down from the horizontal axis and make a tick mark. The line will cross the y-axis at -6. That's the meaning of the y-intercept. So I can place a point there. I can use the concept of the slope. If I'm reminded that slope is rise divided by run. Rise is the vertical change, run is the horizontal change. So with this slope of 1/2, I have a rise of 1 and a run of 2. That means that for every 2 I go over, I go up 1. A run of 2, a rise of 1, from one point to the other. From this point, I could run 2 and rise 1 again to get another point. I could go backwards. If I go backwards, I need to go down 1 and to the left in order to get another point with a rise of 1 and a run of 2. I have several points. I can complete my line by connecting them together. So to keep the process, we'll review what we did. We first put this equation into slope-intercept form. We then plotted the y-intercept. The y-intercept in this case is -6, so it was the first point that I put down on the graph, easiest to find. Then, step 3, use the slope to plot another point. Think rise over run. We have a rise and a run that we identified, and to go from one point to the other, the first point that we started at was the y-intercept, and we rose 1 and ran 2, up 1, over 2. Or we can go over 2, up 1, over 2, up 1. And last, connect the points to complete the entire line.